Good morning. There is no volume from my one participant, but I see that you are here, so that's good. Good morning. Are there any questions? Any questions? I'm getting a chat. Don't think so. Okay. Well, if there are no student questions, feel free to interrupt at any time if anyone has any questions. So I guess I'll just do a few practice problems. So your quiz 2 is tomorrow. And I have identified just a couple of topics that I think are worth looking at. So first I want to talk about the labor market and how kind of some definitions are derived when speaking about the labor market. There are going to likely be some questions on your quiz about defining the labor market and participation rate and some calculations. And even though the calculations are very, very simple, typically just a division to find a percentage, it's still, you'll get the totally wrong answer if you're not dividing the right numbers, right? So it's really important to understand the structure of the labor market. So I just want to draw this out and just follow along kind of mentally or take notes as we go here. And again, this isn't anything new. This is just stuff from the modules it's in your module information, but you may have missed it because I know that there's a lot of material in every module. And when it comes to study time, it's hard to know where to start. And if you don't have time to study it all, you want to make the best use of what little time you do have, right? Scarce resources. Okay, so let's start here with working age population. So of course, in any given country, you've got the whole entire population, but the first slice that we start with is just the working age population. Give me a heads up if you can't see the whiteboard properly. And typically that's about age 18 to 64 or 5 or something like that is I think how Stats Canada kind of parses that out. So we start with that big bucket. From there, we're going to divide it into two buckets. We've either got the labor force, or we've got not in the labor force. So let's do a thought experiment. What's an example of somebody who could be in this working age population, but not in the labor force? For example, someone like a new mom who's just given birth to a baby, and so she's taking time off of work on her mat leave. She's, working age population, but she's not currently in the labor force, okay? So then we take our labor force, and again, we divide it down into two groups. We've got the employed, and that's easy to think of an example. And then we've got unemployed. Okay, I want to talk about a couple of different kinds of employed people. We can have people who are underemployed, and I know that there is a question in the practice in the practice questions in Module 4 about this, about an example of someone who's underemployed. And then we're going to have, in theory, we could have overemployed people. So that would mean that their skills are like inadequate compared to their job. Underemployed means their skills are more adequate. And then we've got everyone here who's kind of the Goldilocks, the just right, I'll call them Goldilocks, where their skills match their job. Or I guess you could say their pay, their remuneration. So people who are in that just right category are not going to be looking for a different job because they're going to just be satisfied with the money that they're earning relative to their skills and education and their job description and what's required of them. So then we've got sort of two broad categories of unemployment. We've got what I'm going to call natural unemployment, and there's going to be three kinds, and we'll come back to those in a second. And then there's unnatural. I'm not sure if the module calls them unnatural or not, but the other word that we use is cyclical. And the reason it's called cyclical unemployment is because, remember in the first, the quiz 1 tutorial, I talked about this business cycle. And this is just a really basic concept that, you know, profs will come back to over and over again in macroeconomics, is this business cycle. And so what it is it's the measure of real GDP or output in an economy over time. And when we're going up towards a peak here, it's what's called an expansionary phase. And then when we're coming back down, it's called a contractionary phase. And so if you were to actually pull real data off of Stats Canada or whatever, and you've probably seen them in the modules, the graphs of real data usually look something like this. It's like really spiky, and if you look really close, it's like lots and lots of really sharp peaks. But for every one of these sort of areas, you can zoom in to this GDP over time graph, and really what it is these ups and downs over and over and over and over and over again. Now, what we don't want to see in an economy is real volatility, up and down, you know, sharp ups and sharp downs within a short period of time. What we want to see in an economy is we want to smooth out those fluctuations. So we want a nice, smooth business cycle. And what you'll learn about in subsequent modules this semester is that there's two methods of smoothing out this business cycle. So two methods of controlling the economy so it's not volatile like this. And one is called monetary policy and the other is called fiscal policy. And really it just means who's making the changes in the economy. Is it the government or is it the Bank of Canada? That's the only difference between monetary policy and fiscal policy. But anyways, so you want to smooth out that business cycle as much as you can. Now, back to the business cycle. The reason why a certain type of unemployment is called cyclical unemployment is because it's just what happens as you move through that business cycle. So as you're going into an expansion, as your economy is expanding, picking up steam, as my 202 teacher used to say, step on the gas, and he would always pump his foot on the floor and make lots of noise. As you're stepping on the gas, you're going to see a fall in unemployment, right? For some reason, the macroeconomic variable that we typically use is U for unemployment, which is the opposite of employment. So don't get mixed up on that, okay? So as we're ramping up here in the business cycle, you're going to see a fall in unemployment. As our economy is contracting and we're coming back down into a trough, into the low point of a business cycle, we're going to see a rise in unemployment, right? And so this unnatural or this cyclical unemployment is just what happens as an economy moves up and down the business cycle. And again, the goal of policymakers and of the powers that be in an economy, the goal is to keep those business cycle fluctuations as smooth as possible, to be able to recognize the signs when we're going into an expansion or a contraction, and to execute the right policy to achieve the right kind of economic fluctuations that you want in an economy, okay? Then we have three types of natural unemployment. We have structural, and the way that I remember what this one is if you ever read headlines, you'll hear about companies doing like a business restructure. They're restructuring. And that's the nice way of saying we're laying people off. So that might be, for example, a business is changing their business processes. They're going lean. Ever heard of lean production? You can look it up. It's this whole kind of paradigm within kind of the corporate world. They're getting robots, let's say. They're going from less manual labor to more robots. And so that would be like a business restructuring. So people losing their jobs, you know, because of robots would be structural. Then we've got seasonal, which is very intuitive and easy. Winter, summer, you know, different industries lay off people, hire more people depending on the weather and the seasons. So that one's easy. And then this last one is frictional. And this, in my opinion, this is the one to worry the least about. And the reason I think that is because frictional unemployment is when somebody is typically temporarily unemployed because they've quit their job, for example, because they just weren't happy with their job, or there's this whole kind of, if you've ever gone into a job interview, a lot of corporations are shifting their culture to put more importance on, is this a good fit? You know, the job to the employee. And there's more to it than just, is this person qualified? Does this person have the experience we're looking for? Can this person use the software that we need them to be able to use? It's more to it than that. It's like personality-wise, or what are this person's values relative to the values of the employer? And honestly, I have found myself in a job and I actually quit. I just straight up quit my job and didn't have a job because my values didn't align with my employer's values. It wasn't that I wasn't getting paid enough. That was fine. It wasn't that I didn't like my job. That part was fine. I got along with my colleagues. I enjoyed my work. I enjoyed my customers. I enjoyed the knowledge that I was gaining. All of that was fine. But my employer as a person, his values did not fit with my values, and I quit based on that. So that type of thing is frictional unemployment. And I think that it's not really something to panic about, because I think it's actually really good for people to quit their job if their values don't align with their employer's values. I think it's really good that companies are starting to have these kind of conversations with their employees and are just starting to put more thought into, is this a good fit? So I think it's just a good thought exercise. Any questions about the labor force before I move on to the next thing? Okay. So the next thing that I'm going to do is work through practice problem 5.1, I think it is. The one with the family. 5, yes. So if you like, you can go to module 5 on your courses, pull up the practice problems at the end of the module, and bring up 5.1 so you can follow along. Sorry, bear with me. This is typically I'm in my office at the university when I do these tutorials, but it's the weekend. Don't really feel like going to university, and my partner just picked up this whiteboard for me, so I thought I'd give it a try here at home. So here I am at home, nice and cozy, and my dog is just hanging out with me. Lubin, say hi. So it's a lazy Sunday. Okay, try and line that up nicely. Okay, so practice problem 5.1. We're going to talk about marginal propensity to consume, marginal propensity to save, and how to construct a consumption function. This practice problem is going to be particularly good for any students who struggle with the algebra in economics. Maybe grade 10 math was a long time ago, like it was for me. I was 28 years old when I started university, and that's a long time since high school. So even if you were good at it in high school, sometimes you forget. Okay, so 5.1 says, consider the following description of spending habits of the Hoyte family. Initially, their income is equal to 0, but Brett and Mila still spend $40,000 a year. So I just want to stop right there, and I want to start graphing this consumption function, okay? So when we're graphing a consumption function, you can go about it a couple of different ways. We're going to be, this question speaks about a household, but I'm also going to make the parallels when talking about a whole economy, okay? Because really this consumption function does build up to looking at real GDP in an entire economy using all of the macroeconomic variables in the AE or GDP function, which is, if you don't do anything else in this semester, absolutely memorize this, because at least if you could write this down on an exam question, you would get some marks. This is the most important formula in all of Econ 202. Y, well, GDP is equal to Y is equal to C plus I plus G plus X minus M. If you don't do anything else this semester, just memorize that. Anyways, back to this family. So let's start graphing this consumption function. So we're going to make a graph here. This, of course, is our y-axis. And on our y-axis, we're going to graph C, which is consumption, which is household consumption, okay? Okay. And just as a refresher, what is I? I is investment, which is consumption done by firms or businesses in an economy. And what is G? G is the third part of consumption, but it's government consumption. So C and I and G are all consumption of some sort, but done by households, done by firms, or done by governments, okay? So we've got C on our y-axis, and on the x-axis, I'm going to put YD, which is disposable income. Okay. Actually, I know that Harvey does a capital Y, capital D, but I kind of like capital Y, superscript small d, just so that I remember that, I don't know, it's just easier for me. It's more intuitive to think of it as disposable income. Now, again, if we were doing the aggregate expenditure function for an entire economy, I'm going to do that in a different color actually, right beside it. The variables would be AE for aggregate expenditure and GDP, or just Y, for an entire economy, okay? So that's what this model builds up to, but I just want to go through the real foundational bits of the model. So, and then let's put units here in dollars, and same thing here in dollars. And if it was for an entire economy, maybe it would be like in billions of dollars or something. Actually, you know what? Let's do this in thousands of dollars. Thousands of dollars. Not hundreds, thousands. You know what I mean. Units, very important. So the question says, when the family has zero income, meaning an X value of 0, they're still spending $40,000, okay? Which means that I'm going to have a point here on my plane that is 0, 40, right? Okay. Next bit in the question. Blah, blah. Next, Mila gets a job, blah, blah, blah. Their disposable income, so YD, soars to $100,000. Now, just a point on YD. If Y is the entire income, entire household income, and YD is just the disposable, what would be the other part? What would be the non-disposable part that would make up the rest of all of the income that a family pulls in? Well, it would be the income that you could say have to go to essential expenses, I guess. And this is going to look different for every household. You know, maybe you really need to pay your cell phone and your rent and your groceries and all these kinds of things to leave you the rest of your disposable income. And then anything that you don't spend on either the essential expenses or disposable income, the leftovers you will save. But we will talk about that after. Okay, so their income now soars to $100,000. So I'm just going to plot that over here somewhere, 100. Now, I don't know yet where we're going to be on the y-axis yet, so I'm just going to draw a line upwards. So soars to $100,000, and their consumption, here we go, the y value, rises to exactly $100,000 a year. So that means I'm going to have another point up here. That's going to be 100, 100, right? Okay. So now it says calculate the Hoyte family's marginal propensity to consume. If you don't understand marginal propensity to consume and marginal propensity to save, spend some time studying it. It's super important, and it's actually, if it looks overwhelming, try to skip over the math part and get to the theory part, because it's actually fairly intuitive. It's really not that hard. So I'm just going to connect these two dots with a line here, and this is going to be our consumption function. And we're going to fill in these numbers here. So what we're going to have here is consumption as a function of disposable income. Just like in high school, we used to graph y is equal to some function of x, okay? Now, my favorite format to do equations is y is equal to mx plus b, which is the slope point format. And the reason I like it so much is because, sorry, not slope. Why do I always say that? I said that the other day too. Maybe it is called the slope point. Slope y-intercept point, doesn't matter. So you need the slope and you need the y-intercept. I think it's called the slope-intercept format to fill this in. Now, m is the slope of any equation of a linear line like this, and b is the y-intercept. Now, it just so happens that in this consumption function, we already know the y-intercept. We already know that this line crosses the y-intercept at 40. So that means, okay, let's do the equivalent here. C is going to be equal to slope, and x is yd plus b. So we already know that b is 40. So let's just plug that in there. So all we need now is to figure out our value for m. Now, the value of m, like I said, is just the slope. And we've already got 2 points here where we can calculate our slope. So our slope of any line is rise over run, which is, this is the rise this way between 2 different points. So what is the vertical distance between point A and point B? Well, it's just the difference in the y-intercepts, the y values, I should say. So it's 100 minus 40. And the run is going to be this way between 2 points. So it's the difference in the x values. So we've got, I took point B first, point B minus point A. So I have to do that again on the denominator. So we've got 100 as an x value for point B and 0 as an x value for point A. So we've got 60 over 100, which gives us 0.6 as an m value. So we just plug that in here. So our consumption function is C is equal to 0.6 yd plus 40. Now I want to look at this intuitively for a moment and think about whether or not this makes sense. And I've got 1 minute left here on my tutorial, so that'll be just enough to wrap up the algebra part here. So what we're saying is, remember when we said that even when the family has 0 disposable income, they're still spending $40,000? So let's run through that in our minds and see if it matches the numbers. So 0 disposable income in a household means that yd goes to 0. So let's set yd is equal to 0 and plug it in. C is equal to 0.6 times yd, which is just going to be 0, plus 40. So consumption is equal to 40 when the family income is 0. Does that make sense intuitively from the story that we heard? Yes. Does it make sense graphically? When yd is 0, consumption is 40? Yes. So the story matches, the numbers match, and the graph matches. If there's anything that I could really drive home for your success as an economic student, is when you're writing an exam and you're doing your question and smoke's coming off the page and you're just in your groove, and then you're finally done and you've got your final answer as a number, and you really should wrap up your question with a sentence that says, therefore real GDP and whatever was this number. But then take a step back and say, okay, does this match with my story? Does it make sense that an economy with these numbers would have this kind of number of a GDP at the end? Am I off by 2 decimal points? Like, really just take a step back and then look at the graph that you put with it and say, do my numbers and my story and my graph all match? If the answer is no, go back and try and find your error, because you've probably done something wrong. Any questions at all about graphing and the consumption function? Okay, great. Well, I had 1 participant today, but thank you so much for participating. I will be posting this for everyone else to see. As always, if there's any questions before the quiz, you need help with anything, just send me an email on UR Courses. I will be monitoring it diligently today. okay, and tomorrow. So good luck, everyone. You're welcome, Haley. Thanks for the chat message.